Project deployment, powering a wireless access point. By the time we're done here, you will understand and select a method of powering a WAP. When you sift it down, wireless access points aren't the only network device that needs power. Nowadays, you have IP surveillance cameras, you have voice over IP phones, even thin clients can get their power over an Ethernet cable. But when you sift it all down, there's really three ways that you can power a network device, including a wireless access points. The most common is going to be power over Ethernet. And the beauty of that is twofold. One, you have a centralized point of power, and that would be the network switch, whatever switch you have supporting power over Ethernet, that sends it over the Ethernet cable. And that means that you can now back that switch up with a UPS system. Now that's awesome because now you don't have to go to every device that you connect and plug in your own little separate UPS. But our UPSs do have to be bigger to handle the wattage that starts being drawn out each one of those Ethernet cables. The other advantage of using a switch to power the device is you can access the management of that switch and turn power over Ethernet on and off. That's a huge benefit of power over Ethernet because a lot of times our network devices will freeze, as in we can't access them via the management interface. And if we've used one of the other methods of powering our device, that means we have to physically go and unplug whatever that is and plug it back in to reboot it. There may be times where you're at a location and they don't have a PoE switch, so you just go, let's just install a plug. But also remember, where are those wireless access points? They're oftentimes in the ceiling, and it's actually against code in most areas to put a plug above the ceiling. You actually have to have it sticking out below the ceiling. How ugly is that, to where you have that plug now coming out and then back up into the ceiling to plug into that wireless access point? Usually if you talk to the business owner and you say, hey, we've got 2 WAPs and I've got to run electrical cable, and it's going to look nasty. It'll more than justify the expense of buying a PoE switch. The other thing worth mentioning is that there are proprietary PoE types out there. And they were created likely because the manufacturer could do it cheaper than setting up industry standard power over Ethernet. So beware of that, because when you buy the device, you may say, oh, that's a really cheap device. And I specifically am thinking about UniFi wireless access points when I think of this. A lot of their really low-end devices, meaning somewhere between $60 to $80 per WAP, require that you have one of these 24-volt PoE injectors. It's not a standard power over Ethernet. So that means you're either relegated to using these PoE injectors for every single wireless access point, which these have a plug in the back that goes into an outlet. And you can imagine with 10, 20 different WAPs, before long, you've filled up an entire block of power just plugging these things in. Or it requires you to buy that vendor's specific switch. For instance, Ubiquiti creates switches that allow you to use their proprietary PoE. So I'm not too sure if that's their main motivation or if they just were able to manufacture it cheaper. But I know I've been burned more than once buying something and I go, it doesn't even work with standard PoE. Because power over Ethernet will be the primary way that you power these devices, let's look at the standards that are available. First off, there are 2 that are currently out, 802.3 AF, which is the original standard, and 802.3 AT, which was added later. This one caps out at 15.4 watts per port, which is good for most devices out there. But when you get into the high capacity devices, for instance, I put a little chart here of all the UniFi WAPs, and this is just an example. For every vendor that's out there, they have a chart similar to this showing the type of device that's there and the PoE standard, or we'll say substandard, that it's ending up using. So you can see 802.3 AF, which is our 15.4 watts per port, is acceptable on things like an AC Pro, an AC in-wall. It's one of those wireless access points that actually installs as a wall jack. Pretty cool. But when you get to the higher end devices like this AC HD, which is a high density wireless access point, it's only supporting 802.3 AT because it needs that extra power to be able to support the capabilities it has. Now you see in very small little starish font, a couple asterisks after that. And I just want to, I don't know exactly what that means, but what I will say is a lot of devices that support 802.3 AT will support a lower wattage, but it will disable some of the higher capacity features. For example, you might have a video surveillance camera that works just fine with 802.3 AF, but maybe the motor will not function that allows you to rotate the video camera around. Now there's one coming out that I'm kind of excited about, but I'm not too sure how to take it. 802.3 BT. And with the power of video, maybe by the time you're hearing this, it's already out there. But look at the power capability it's able to produce, 55 to 100 watts. Now, initially that sounds awesome. I'm like, good grief, we can just plug our computers into an Ethernet cable and not even have to worry about power throughout our building. But then I started thinking about what kind of power supply would I have to have and what size of UPS would I need to back things up? I guess the beauty of that standard is it gives you the ability to make that decision. Do you want your entire company to keep running off the grid? Install solar panels, gas generators? Are you going to build your own data center? That's kind of the feel that I get when I look at that standard. But by having such a high power capacity, there's going to be a lot of features that we're able to support with that. Okay, last thing I want to show you. I just telnetted it into a Cisco switch here at the office. And I'm going to type in the command, show power inline consumption. What this will show me is how much power over Ethernet is being drawn out of this switch. Now, the first thing that I see is the power limit is 31.5 watts per port. Now, you might look at this and go, well, that doesn't align with any of the standards that you showed. Well, keep in mind these values here on the screen are the actual deliverable values that each one of these ports can send. It's kind of like the miles per gallon that your car is rated at. Even though it says you should get that amount of gas efficiency, you know you never do. Same thing here. This is an 802.3 AT switch, and I also telnetted into an 802.3 AF switch. Notice the difference. Power limit on this guy is 16.9 watts, of which it can deliver 15.4. Now, over on the left-hand side, you can see the actual wattage that is being delivered at that port. Now, that's pretty great to see because you can see that even though it can deliver 31.4 or 25.5, it's only needing 3.6. So it's only consuming what it actually needs. Now, the temptation is to over-provision a switch. Be like, well, I don't think it's going to need as much because it looks like this device only consumes 3.6, this is 2.5. What these likely are is voice over IP phones that are sitting in an idle state. Maybe this one has a backlight on the display and this one does not. But the truth is, once you pick that handset up and try and make a phone call, the device will consume more wattage. So while this does give you the actual consumption on the switch, it's not a very realistic view of what is actively being consumed. It's just a snapshot in time. You can see this device right here is 9.9 watts. That's very likely a WAP. So every manufacturer of switch that supports PoE will have some kind of interface like that allows you to see what's actively being consumed. Before you just go out and purchase wireless access points for your deployment, be sure that you know what PoE standard they're going to support and ensure you have the switch that delivers that PoE standard and can deliver enough of it for all the WAPs in your environment. Well, I hope this has been informative for you, and I'd like to thank you for viewing.